how much larger is the Sun compared to the Earth? The comments on many popular science sites are surprising because so many people take illustrations like this seriously. But neither the proportions nor the distances of them are even close to reality. In fact, the Sun and the Earth, when placed next to each other, would look like this. The diameter of the Earth is 12,742 kilometers, and that of the Sun is 1,392,700 kilometers. That is, there would be enough space from one side of the Sun to the other to accommodate 109 Earths, with a little more room left over. That's already pretty impressive, but it's still not entirely obvious just how huge the Sun really is. So here is a clear demonstration. If we neglect the voids between these spheres, about 1.3 million Earth planets would fit into the Sun. We'll give you a few seconds to realize that. Although this realization is quite invigorating, it's all just a warm-up. The Sun, despite its hugeness, is a pretty ordinary star. There are stars bigger than the Sun, and everyone who's even slightly familiar with the subject knows that. But not everyone can even imagine to what extent other stars can be bigger than the Sun. There are giants, there are supergiants, and then there are hypergiants. Let's focus on them, the hypergiants. Giant stars. Meet the first one, the star KY Cygni. Whereas the Sun can accommodate 109 Earth planets from edge to edge, this monster can easily hold as many as 1,000. Not Earths, but suns. All this complicates the analysis, and therefore there is still no consensus about the exact size of the KY Cygni. But one thing most scientists agree on is that it is one of the smallest hypergiants. Yes, this star is even sometimes referred to as a boundary star. An object with less luminosity would no longer be considered a hypergiant. But there are stars whose hypergigantism no one doubts, and discussions are held only about the exact size and properties. For a long time, this star has been the undisputed leader in terms of proven size. And even now, after most scientists have demoted it to at least second place, it remains incredibly interesting. This is VY Canis Majoris. Located at a distance of about 3,800 to 5,000 light-years away from Earth in the constellation of the same name. There is no unequivocal opinion about its size, as in the case of the KY Cygni, but most stick to an estimate of 1,420 sun-wind-blowing size. The mass of VY Canis Majoris is estimated to be 15 to 25 times the mass of the Sun. No, not 15 to 25. And now, finally, we move from the former leader to the current champion. Stephenson 2-18 is a bright red hypergiant in the Stephenson 2 star cluster in the constellation Scutum. This star is much farther away from us than the previous two, 18,910 light-years away. That said, it's even slightly better studied, although there are still discussions about its size. And even the most realistic figure looks absolutely exorbitant. 2,150 sun radii. Put in the place of our Sun, the star Stephenson 2-18 would absorb Mercury, Venus, Earth, Mars, and even Jupiter, and would reach the orbit of Saturn with its photosphere, basically its surface. So here is a clear demonstration. If we neglect the voids between these spheres, about 1.3 million Earth planets would fit into the Sun. We'll give you a few seconds to realize that. Of the star is about 10 billion times the volume of the Sun. Just recall the beginning of the video, where the Sun accommodated 1.3 million planets Earth, and imagine 10 billions of suns. That's just a whopping, unimaginable volume. We are lucky with our Sun. It was born far away from such zones, and that's really fortunate. Areas of star formation are like a real furnace, a melting pot, a forge. It's almost impossible for Earth-type life to originate there. Our Sun was born in a quiet harbor with perfect conditions for the cradle of life, away from all those space monsters. We'd rather watch them from afar.